my name is Will Angel, and I'm going to be talking about building a personal data lakehouse. So I'm going to give you all the summary up front. I built personal data lakehouse. I call it P-Lake. It's got a command line interface as well as a front end that you can see a screenshot of here. And it's built with Python, SQLite, and Parquet. SQLite serves as the data catalog and the query engine. Data is stored primarily in Parquet with some native file format storage as well for images and video, and some links in place for larger external videos. It all runs locally or on my local network attached storage device, though that's sort of dual client mode there. And it's primarily a rich-based command line interface and then fast API HTML front end. The data lake also does enrichment on ingested data, specifically uses Whisper for transcribing audio and video, and then does OCR on images that have text, and then does some cool stuff with machine learning to detect animals and tag those animals, which, like I said, was the primary impetus for actually doing this doc. And the big thing is it gives me integrated search across all my data. I'll show you some examples of that, but this is super useful and is done primarily with BM25 and SQLite's full text search. So, and I'm going to give you the key takeaways that you should think about for building data systems before I dive into them more. I've also got a screenshot of the front end showing search and an OCR'd image. So my key takeaways, got two primary ones. One is be mindful of your data access patterns. Data creation and the way that you access your data really drives all the architectural decisions. And consider your data because the variety, volume, and velocity of that data is really going to influence what you actually need and build. Consider your non-data requirements as well. Things like security, RBAC, like we just heard, compliance, and then reliability and robustness. So now that I've given you the bottom line up front, I'm going to give you the overview. I'm going to answer the question, what is the data lakehouse? Why would I build one? Some of the considerations there of building it. I'm going to talk a little bit about the differences between an enterprise TM system and what I've ended up building. And then I'll talk a little bit about actually building the personal lakehouse. So what is a data lakehouse? The data lakehouse combines the best features of a data lake, like decoupling storage and compute, which makes it cheaper to scale, open storage formats for flexibility and lock-in, or less lock-in, with the best features of a data warehouse, which gives you more powerful and ergonomic abilities to query and aggregate data. Nice things around governance and structured schemas, and then less file management, because having to manage all the files yourself is kind of a huge pain. So why build a personal data lakehouse? And there you got to ask the question, why build any data lakehouse? And that's because we have data and want to manage it. I've got a screenshot of the management view here that I have for P-Lake, and you'll note it's got a bunch of different data sets and things, and I've got about 1.5 terabytes of data, of which most of that is actually photos. And yeah, I've had this on a bunch of different hard drives, a bunch of different computers, in the cloud, some local, and data it's only useful if you can actually use it. And the less managed it is, the harder it is to use. So by bringing this all together, a data lakehouse, personal or not, is actually very useful. And just to give you a sense of the scale, I have over 250,000 photos from years of doing amateur wildlife photography. So that's quite a lot of photos to manage. And I also have a lot of other siloed data. I've got documents, emails, chats, browser history, photos, memes, wildlife photography in addition to the regular photos, wildlife videos, some regular videos, some movies, all that good stuff. So a lot of data in different places that you can kind of search through it in the like file system and all that, but that gets not very ergonomic, not very useful. It's like if you've ever had SharePoint or Google Drive with just a billion things in it, you can't really use that. I've got a screenshot here of the statistics view that has some things around like activity over time as far as when records were created and some fun things around email analytics. So let's talk architecture. When you build a data lakehouse, this is an Australian boo-book owl, by the way. When you build a data lakehouse, or a data system of any kind, you have a couple of architectural considerations, and the data is the most important part. And you've got the 5 V's of data, which are velocity, how quickly you get new data, volume, how much data you have, variety, the different formats and types of data. And these 3, I think, determine your data system complexity, where the more volume, velocity, and variety you have, the harder and more complicated your system is going to be. And then you have veracity, how trustworthy or correct is your data. And then the last, and I think the most important one actually, is value. How useful is your data? Because all these things, these considerations that go into building a cool system, they don't actually matter unless the system is useful to someone. And in an enterprise setting, that means like it helps people make money or sleep better at night. You also have some non-data architectural considerations, things like user access patterns. Are your users going to want a GUI and auxiliary tooling? Here you can see on the right, I've got a catalog view that I made. If this looks a lot like Databricks and some other things like that, it would be inspired by that. Also look at questions like, are your users going to do a lot of interactive querying? Are you going to need compute for that? And if you have a lot of them at once, what's that going to do to performance? And reliability, if you have a lot of people doing a lot of querying, what does that do for your availability and latency? And so you need to think about how you're budgeting both cost-wise and overall observability and monitoring for that. You've got maintenance considerations around how much time do you actually spend maintaining your system and your data. Backups and recovery mechanisms. If something happens, where's your data? Is it backed up? How do you recover from that? And then security. It's important to have secure access and RBAC, which are role-based access controls. That's what's mentioned in the last talk. Things that enables you to do field row and column masking, which, if you have enough people and enough data, is a very cool and important capability. You've got compliance. If someone changes something, can you see what happened with audit logs? SOC 2, HIPAA, et cetera. And then cost. How much does it cost to actually run the whole thing, and does that meet your budget? Because if you have a lot of money, I used to be a consultant, I'm happy to build you something that will use as much or as little money as you want. The more the better. So, I've done a bunch of enterprise TM work in my career, and that's not always appropriate for either a company. Maybe you don't have the same requirements everywhere, and for a personal project where there's only one user, me, you don't need a whole lot of stuff. So I'm just going to say, the system I built is not enterprise grade. I've built enterprise grade systems, and this is not that, and it doesn't need to be. I've got a screenshot of the query interface here, so I can actually go into the system and write SQL in the HTML front end, and that's pretty cool to be able to actually look at photos. You'll note that the actual query there is calculating the area of pixels, and that top size is my nice Sony mirrorless camera. So to talk about the data differences between my system and enterprise system, you've got the volume, the velocity, the variety, veracity and governance, and enterprise is a pretty wide distribution depending on what the enterprise is. Sometimes you have enterprise systems with small amounts of data, sometimes huge amounts of data. I think one of the other talks today is on building an exabyte scale data lake, which is pretty cool. My data is annoyingly medium, definitely won't fit in Excel, but it doesn't quite fit in memory, and but fits on a hard drive, big hard drive. But for velocity, mostly I'm doing weekly batches. In enterprise, I've seen quarterly data jobs that are super valuable, and I've seen sub-second real time. For variety, I unfortunately have lots of photos, which are in annoying data format alongside audio and video. So I think in most enterprise data lakes, generally you're using structured tabular data, and that makes things usually a little bit easier to manage. But then on the governance side, for me, I was focusing mostly on ingestion integrity, making sure that when I brought data in, it was good. That's important for an enterprise, but in an enterprise, it's not just is the data correct, is it coming in right, but also where did it come from, who knows what it does, how do you understand that, lineage, governance, discoverability. Those are a lot more important when the data doesn't mostly fit in my head. share a little bit of experience about actually building it. So I started with the core data catalog, implemented that, and then added the first data source and iteratively added features and additional data sources. This is the way that you should build every data system, because if you do it all at once, you're never going to finish. I will say, agentic coding, there's still a lot of places where it leaves room to be desired, but for greenfield projects, it's fantastic. Cloud Code, Cursor, and Kilocode got me to do way more than I was originally expecting feature-wise. That said, testing is essential because I had places where, the agents implemented something and broke something else, so that's important. And I will say, you can do a lot more with agentic coding, but even frontier models need to be steered and prodded to do pipelines correctly, because things like idempotence, backfill and sync logic, they're getting that all to work, not just on the happy path, but on the unhappy paths. That still requires a lot of prodding and expertise. And overall, the hardest part was deciding, how much did I want this to be more like a data lake or a data warehouse? And Data Lakehouse is the sweet spot because you get the best of both worlds most of the time. But that's sort of the inherent tension and was part that was hardest about this. And got just a few more points before moving to the Q&A. Being able to search through all my photos with metadata ML generated tags is super cool. Local ML models are getting really good, not just for LMs encoding, but for actually doing image recognition. And the better your data is, the better you can actually use AI, because I wasn't able to do all this cool ML tagging until I brought all the data together. And then, open source tooling for all this stuff is really good, which is why we're having this conference. And with that, that's my talk. Thank you.
Yes. Will, awesome to see what you've built. I am so stoked on that. I have a few questions while people are typing away asking their questions. Number one, on that last slide to the last slide, most pertinent questions are, what models were you using? How big? What are we talking here?
Ooh, for the image recognition or the coding?
Yeah, both.
Both. For the coding, it was a lot of Cloud Code with like Opus 4.5, Opus 4.6. For Cursor, a lot of the actually Composer 2 is a remarkably capable model. And then for OpenCode, usually either like the Kimi K2 or some of the Quen models. Those are quite good. For the local image recognition, for OCR, I was using just like conventional off-the-shelf non-machine learning Tesseract, which is very robust. And then I was using the variant of the iNaturalist model for doing animal tagging, and then using a model called Megadetector V5 for actually recognizing that there was an animal.
Nice. All right, very cool. And you had to give, like finger to the wind, how much of this whole project was vibe coded? What are you saying? 100%? 90%?
So vibe coded, like places where I didn't actually look at the code, I'd say 10%, maybe 20%, because making sure that this actually worked and moved my data around in the way that I wanted. I built this so that I have enough confidence where if I had to delete all other copies of the data, I'd still be a little nervous, but I'd be willing to do it.
Excellent, dude. It looks like, what do we got? Have you found ways to model relationships between items, or most of the meaning carried through tags and queries?
Ooh, yeah, that's a really good question. So there, if things are tagged the same, you can search that. With the search that I have, it is BM25, so you basically get a sort of score, and at some point, I'm gonna add like vector search and semantic similarity search. But all of these things, they're all sort of modeled as generic data assets within sort of subcategories based on the actual source. And so there, all of that metadata, you can model it, you can connect it.
Yeah, that's a very fun one. Just thinking about, like I'm sure you've seen how popular it's getting. What is it? Now I'm blanking on it, but like LLM wiki stuff and their Obsidian, all of that, and how it's kind of in that same vein, but not quite.
And I now have all the data and metadata needed to put that together. This background photo here, which is a Weddell seal, by the way, I took this in Antarctica, and it's got the metadata, location, and time, and can probably put that together with the emails that I have about scheduling that trip, who I did it with. So we could put that all together into a nice knowledge graph.
Wow. All right, last one for you. Could you implement, or could this implementation replace the defunct personal desktop Google engine?
Ooh, so short answer is kind of. You could definitely use this. Like the whole point of this is that it is personal search for all the things, all the data that I have. There's no reason why I can't put other external data in this and do like federated search or bring other data in as assets. So you definitely could do that.
Cool. Well, man, thank you for this. We're going to keep it moving.